talk about expectation, which is often referred to also as expected value. So let's suppose that you get to spin a wheel of prizes for a cost of $6. There's a 1 in 3 chance on this wheel of winning $15 and say 2 in 3 chance of getting nothing. If you were to play like 10 times, like on average, how much money would you expect to walk away with from this? Like how much money you're going to make or lose from this interaction, right? So you're paying $6 every time, right? So if you win, you're not really winning $15, you're winning $9, right? So you really have like a 1 in 3 chance of winning $9, right? So 15 minus 6 is equal to 9, so that's your payout for winning. Well, what's your payout for losing, or not really payout, but what's your loss? Well, there's a 2 in 3 chance of losing, and like you're getting nothing, right? But you're paying $6 for the chance of getting nothing. So you're really losing $6 every time that you lose. And there's a 2 in 3 chance of doing this. So there's a 2 in 3 chance of losing $6. So there's a 1 in 3 chance of making $9. So on average, you're going to get $3 from that. And then what's 2/3 of 6? Well, 1/3 of 6 is 2. So 2/3 of 6 is double that, which is 4. So $3 minus $4 is negative $1. Forgot the negative. Okay. Well, if we're going to play 10 times, then on average, we would expect to make or lose 10 times this amount. All right, so we're going to lose 10 times this, so we're going to lose $10 on average. Okay, so if you were to do this like a bunch of times, you would expect this result here. So that is what expectation is. Like, so if you were to play like once, you would expect on average a loss of $10. And of course, like if you play once, like you're like losing $1 is not a possible option. So it doesn't really make sense to say like I'm expecting to lose $1. It makes more sense to think of this in terms of if I were to play a bunch of times, then if I were to look at like what my result is like at the end of those $10 or at the end of those 10 spins, if I were to compare my bank account like at the beginning to my bank account afterwards, it should be like about $10 lower. So that's kind of what expectation means. Expectation is all about like averages over repeated attempts. So a little bit more formally, if S1 through Sn are the possible numerical outcomes of an experiment, so like S1 through Sn in the previous example were just like the payouts. So like our numerical possibilities were gaining $9 or losing $6. So plus 9 or negative 6 was our S1 and S2. And P of S1, P of S2, P of S3, and so on, these are the probabilities of those outcomes. To get our expectation for the experiment, we could just do the same exact computation we did in the previous slide, which was just multiply the probabilities times the numerical outcomes associated to those probabilities. So probability of S1 times S1 plus probability of S2 times S2. So in the previous one, we had, so let's bring this over here. So we only had an S1 and an S2, and our P of S1 was 1/3, our S1 was $9, our P of S2 was 2/3. Our S2 was not $6, but it was actually negative $6. So I'm going to make this a plus over here, and then just make our S2 be like negative $6. Right? Doesn't affect our computation in any way. It just, technically our S2 would be we lose $6. Okay. Anyway, so another easy example of this. So let's suppose that a coin is flipped. If heads is flipped, you win $20. If tails is flipped, you win $10. Okay. So here, S1, the expected, the numerical outcome of flipping heads would be $20, and the probability associated to that is 1/2, right? 1 in 2 chance of flipping heads. S2 is $10. That's the numerical outcome associated to flipping tails, and the probability associated to that is 1/2. So to get your expectation, you do P of S1 times S1, that's 1/2 times 20, and then plus 1/2 times 10, and then 1/2 of 20 is 10, 1/2 of 10 is 5, add those together, you get 15. So the expectation for this game would be, on average, you would expect to make $15. So if you were to play this game like 10 times, then you would expect to win about $150. Like maybe you get $20 like 5 times, and you get $10 the other 5 times, which would give you 150 total. I don't know why I'm circling 15, but you get like 15 times 10, whatever. Okay. Cool. Let's do like another sort of simplified example of profit and loss. So let's suppose that the probabilities of a company's profit or loss for this month are given by the following table. So this is a very unrealistic table, mind you, but like you can kind of think of this in terms of like this can generalize to like much more complicated examples, obviously. This is very simplified. So what's going on in this table? Well, it's telling us that there's a 20% chance of making a $10,000 profit, right? So 0.20, that's 20%, or 20 in 100 probability of getting this profit of $10,000. The probability of getting a profit of $5,000 is 35%. Probability of getting $1,000 profit is 30%. And then here we have like a negative value, so this would be not a profit, but a loss of $1,000. And there's a 15% probability associated to that. So our expectation, we can just, again, compute in the same old way of just multiply our numerical value times its associated probability for each of these, and then add them all up. So 0.20 times $10,000, and then plus $5,000 times 0.35, plus $1,000 times 0.30, plus 0.15 times negative $1,000. I forgot a dollar sign here, but oh well. And then you add all these up, and you get $3,900. Okay, and so this would be like how much, like on average, would the company expect to make? And again, they're not this is not like technically a possible outcome according to this table, but if you were to repeat this experiment over like many months and look at like how much are they making on average, it would be about this. All right, roulettes, gambling in general, lotteries are all like a very good sort of lesson in expected value. So in roulettes, half the numbers from 1 to 36 are colored red and half are colored black. The numbers 0 and 00 show up there as well, and they are colored green. So if a player wants to place a bet on red, then they'll win double their bet. What would the expectation of a $100 bet on red be? Okay, so if you're not really familiar with roulettes, basically there are the numbers 1 through 36 as well as 0 and 00. A player can say, I think it's very likely that I'm willing to bet that a 10 is going to that you're going to spin a 12. So they spin the roulette wheel, and then the little ball like shows like picks one of the numbers, and then you bet on the number, right? And then you get a payout associated to that. So the payout for correctly guessing red is just like it's a 1-to-1 payout. So if you pay $100, then you get back double that. So you would win a net of $100. Okay, So let's compute the expectation here. So what's the probability of winning? So they're betting that the player is betting that they're going to get a red. And so how many outcomes of red are possible here? So half of the numbers from 1 through 36 are colored red. And then the other half are colored black, and then the numbers 0 and 00 are colored green. So half of 1 through 36 are red, half of that is 18. So there are 18 reds in this, right? How many total are there? Well, there's the numbers 1 through 36 as well as 0 and 00. That's a total of 38 possible outcomes. So this is our sample set, has 38 things in it, and then our event has 18 things in it as well. What's the value for red? So if they're doubling their bet by winning, then they would win $200, but they had to pay $100 to get that win. So that is a net of $1,000 value for if a red is spun. All right, what about for black or green? So we could handle black and then green separately. That would be perfectly fine. I'm just going to handle them together because they have the same outcomes, right? So it's basically either red is rolled or it's not. So if red is not rolled, well, it could either be black or it could be green. Half of the numbers 1 through 36 are black, so there are 18 blacks, and then these two are green. So 18 plus 2 is 20. There are 20 other things besides red, so 20 and 38 chance of not getting red. What is the value for if this happens? Well, you don't win anything, but you paid $100 to participate, and so the value, the numerical value for spinning a black or a green would be a net loss of $100 just from what you bet. So what's the expectation? I can now just add all these up. 18 over 38 times $100 plus 20 over 38 times negative $100 is equal to, rounding to the nearest cent, negative $2.63. So you would expect on a $100 bet to, on average, lose $2.63. So if you were to go and like say, I'm gonna just like play roulettes, I'm gonna do like $5 bets for a while and see how much I get from the betting red strategy. On average, by the end of the night, if you're spending $100, you would expect to lose about $2.50. All right, I'll let you try the next one. So let's say that they don't want to bet on red. Let's say that they want to play a little bit more risky. They want to bet on like one specific number. So in roulettes, a bet on one specific number gives a player a payout of 35 times their bet on that number. It's according to the textbook, at least. Okay. So suppose a roulettes player places a $10 bet on each of the numbers 1 through 6. So in total, this is like a $60 bet because they're placing 6 bets. Okay. What is the player's expectation? So I think this is a good chance for you to pause the video, think about like kind of what happened in the previous example, and see if you're able to attempt this one on your own. So I'll give you a couple seconds to pause and then come back to this and compare answers. All right, so here's the expectation. The expectation is as follows. So they either win the bet or they lose the bet. So what's the probability of winning the bet? So there are 6 ways to win the bet, right? So there are 6 total options, and then there are 38 possible outcomes on the board, right? So their probability of winning is just 6 in 38. Well, how much do they win if they win? How much do they win if their $10 blade cashes out, right? So you get a payout of 35 times your bet, and they bet $10 on each of these numbers, so they would win $350. But how much did they pay? Well, they paid a total of $60 across the 6 bets that they made. Right? They're making like 6 bets at a time, so it's a total of $60 that they're paying to do these bets here. But if one of their $10 bets cashes out, then they make $350. All right, so their cash out would be $290 net. All right. Well, what about losing? Well, losing is a little bit easier because they're paying $60 every time that they make these 6 $10 bets. And, if there's a 6 in 38 chance of winning, then there's 32 other options on the board. So 32 in 38 chance of losing $60. Computing this expectation gives you approximately a loss of $4.74. I put the negative in the wrong place here, but whatever. So a loss of $4.74 would be the expectation for this bet. Yeah. All right, cool. So that's it for that video. Thank you all for listening, and yeah, that should be the last video of the semester too. So I hope you all had a great semester. Thank you all for bearing with me through all of this, and yeah, hope you learned something.